Okay, Daniel. Okay, Philippe. And okay, whoever else is looking at this. I think you've been ill this week and therefore haven't been around to come to lessons and find out about the project. Indeed, I think if you're in Mr. Vaughan's class, I don't believe he's been able to teach you this week as he had no scheduled lessons. So I'm going to quickly go through what you need to know in 15 minutes or so, and just explain the new project and set up the homework that you need to do. So the new project is called Board. It is focused on making a breakout board for your Genie 14. So without further ado, let's get on. You'll be given a booklet where you need to write your name and your teacher's name on. But it would be good if you did some work to prepare yourself for next week. So second page is an evaluation of the DICE project. What you need to do is you need to look at your DICE project and think, whereabouts did you make errors and what could you have done better? So let's read this. Evaluation of DICE project. During the last project, you produced lots of good work. Some of you even managed to make a working DICE by the end of term. However, many of you encountered the same problems that prevented you from making significant progress. In the table below, list the 5 main problems you encountered and try to work out what you need to do so it doesn't happen again. So you might want to look at, for example, the programming. Maybe you didn't finish the program. Maybe it was your time management wasn't good enough. Maybe your soldering was very blobby or you weren't putting enough solder on. Maybe it was the board design wasn't very good, or maybe your board was scratched because your mask was all scratched, or maybe it was the development, you didn't develop your board enough and therefore the etching wasn't particularly good. I'm sure there's lots of things. Maybe the labeling was bad. There's lots of things that could have been improved to make your life simpler when it came to soldering. So I want you to put those 5 areas down, and then what I want you to do is I want you to justify what you could do this time to make it better. Once you've done that, we're going to come back to this at the end of the project and see if those modifications, those changes that you've made a difference to your next project. Without further ado then, let's go on to page 3. Right, the objective in this project, I want you to draw your own circuit and PCB for the Genie 14 breakout board. Make your own PCB, create a visual diary showing the manufacture of the breakout board, complete a variety of programming tasks and document each program, solder up a variety of inputs and outputs, make a Dyson-inspired control panel to house your PCB, and complete 9 homework tasks. Now, I appreciate at the moment that's all probably sounding a bit double Dutch, if that's the word they use. You know, you don't really understand that. So I'm going to go through it in just 2 ticks. But first, let's just have a little think about the specification. We're going to be making something which is a circuit board that is going to be clipping into or attaching to a control panel, which is going to be made out of probably acrylic. Okay. Now, what does this product need to do? This product needs to have a control panel inspired by the company Dyson, be finished to a high standard, as we would expect, have 5 working inputs, have 6 working outputs, have an on and off switch, show how ergonomics has been considered in the control panel design, have a programmable timer lasting between 1 to 6 minutes or similar, have strain holes for all the off-board components, show evidence of high quality soldering, show evidence of well organized PCB design. Now, I imagine that you're familiar with each one of these 10 points. And of course, to get top marks, you need to satisfy each one of those criteria. However, but first, imagine if every time you wanted to create a new electronic product, you didn't need to design and make a new circuit board. Rather, you created a PCB that allowed you to easily connect and disconnect inputs and outputs as you needed. Sounds promising. If you want to see your homeworks, you can just get your QR code reader, or you can get your camera from your iPhone. Click on that and you should be able to go directly to the homework tasks, okay? Let's go forward to page 4. To approach this, start visualizing your PCB differently. Think of them as a pink wafer with 3 layers. Each layer represents a separate printed circuit board that can be stacked on top of each other. The top layer is used for the inputs, the middle layer, the processes, and the bottom layer, the outputs. By ensuring that each layer functions independently, debugging becomes much more straightforward and the entire circuit is tidier and more adaptable for use in other projects. And we can see here, we've got the inputs on the top, we've got the outputs on the bottom, and in the middle, we've got the processes. So the inputs would be all your buttons, for example, your outputs could be all your LEDs and maybe a buzzer, and the processes in the middle, well, that's largely going to be a Genie. Maybe there's a transistor, maybe there's something else like a relay. Okay, let's go on to the next page, page 5. The middle process layer of your pink wafer could be centered around a Genie 14 chip, making use of its inputs and outputs. Imagine making the electronics for your main GCSE project in the second term of year 10. That's right. We may well be using this circuit board in your GCSE project, okay? So make sure it's of a high standard and make sure you do it to the best of your ability, because if it's rubbish, there's no way you can use it. And to be honest with you, if you were to use it, you would save yourself so much work. But to that end, just in case you use it, what you want to be doing throughout the next 6 weeks, 7 weeks is it's longer than that, 11 weeks. You want to be making sure that you document, you get photographs of all of your work, okay? That is all of the etching, all of the soldering, all of the design work. Therefore, then you can use it in the following product. This is an Arduino breakout board. However, what are these black bits? What are they? Any ideas? Any ideas? Ed, do you know? What are the black bits?
Are there sockets?
Yeah, Ed just told me they're sockets. Absolutely, they're sockets, and they allow cables, solid core cables, effectively, to be plugged in and to be taken out, and then plugged in and taken out. So it's a bit like soldering, but it's just not permanent. It's a bit like a breadboard, but on a circuit board. However, what's the deal with a telephone exchange? Back in the 50s and 60s, making a call wasn't as simple as pressing a button. Telephone exchanges relied on real people, operators, who manually connected your call. You want to chat with someone? The operator plugged your line into a small socket on their switchboard. Need to disconnect or call someone else? No problem. They just unplug and reconnect. This process allowed calls to be made locally or across the globe, proving how powerful a few sockets and some human ingenuity could be. This is pretty good, isn't it? Now, Ed earlier said to me, does that mean that each one of these sockets represents a different person? Probably not. It's probably that each person had a code, and then you would connect different numbers of that code together via the cables, and when you did that, you would then go through to a specific telephone line. Okay, so it's quite interesting, this. However, when we think about it, it's very similar to a system diagram. Remember a system diagram? Inputs, processes, and outputs. Under your inputs, you've got all your buttons. Your processes, you've got your Genie chips, and maybe your transistors, and then your outputs, you've got all of your LEDs. So what have we got here? Inputs, you dial a number, sending a signal to the operator. That's the input to this process, I suppose you'd say, or this scenario is better. The process, the operator figures out where you want to call and connects your line by inserting plugs into the correct sockets. And then, of course, you've got your output. The recipient's phone rings and you're connected. These sockets weren't just holes. They were the key to controlling who talked to whom, showing just how important inputs, processes, and outputs are in creating connections. The humble 4-way PCB socket. These beauties cost just 6p, but can transform your PCB. These are effectively what we saw earlier with the Arduino, but equally well, they give us the versatility of what we see at the telephone exchange. These are cheap, easy to use, and can provide access to the inputs and outputs of your circuit by using a piece of solid core wire. Essentially, they can connect the middle layer of your pink wafer to the top and bottom, or inputs and outputs. Cracking, eh? Right, and then it's the instructions on how to wire up. We're going to be doing this next week, next lesson, week 2. But now, what I want you to do is your homework. Now, as I said, you can find your homework out from page 3, going on to the homework tasks. But fortunately, I've actually got it here somewhere. Oh, I'm having trouble. Ah, I know what I've done. I've got it on the different board. Just bear with me. Here it is. So, homework, Lent, week 1. You've got this on your team. It's a Dyson case study. So, what do you need to do? You need to put a title first of all. What's a title, Malik? What's the title?
It's the top. It's for your case study.
That's right. A case study into James Dyson. Absolutely. And then we've got the introduction. Victor, what's the introduction?
Like a brief summary about the person and what you're doing in your case
A
study.
brief summary of what you're going to be doing on your case study. Once you've done that, you need to put a title, intro, an overview of the company, why the products have been popular, and so forth. Once you've done all that, guys, what you need to do is upload 10 to 20 images and make sure it's got clear and attractive presentation and a conclusion. Okay, I want this done by Sunday, so there's no excuses, and then we can mark it next week. All right, guys, I hope that makes sense. If you've got any problems, just contact me, but I expect the work to be in, and I want it to be to a very high standard. Will, why do I want the work to be to a very high standard?
Because that's good.
Because that's good. It's not just that, is it? That's right, Max, because we might be using some of this work in your GCSE coursework. So rubbish work now means
Rubbish work at your GCSE.
rubbish GCSE coursework. And that then means rubbish mark for your GCSE. So make sure it's of the highest standard so it can be submitted later. Arav, going anywhere? All right. Best of luck, boys.